Thanks for being a good teacher.
Oh, thank you. Thank you guys for being good students. All right, so
The best teacher.
I'm my own personal best teacher. Thank you. All right, so today is Thursday, January 9th, 2020. Make sure your name and date are on your notes. Yeah, so solving similar triangles. We are doing the easy version today. Tomorrow is going to be the hard version. So let's make sure that we definitely get a firm foundation today. Objective. Who wants to read it? Julian.
Use properties of similar triangles to solve for missing side lengths.
Thank you. Yeah, if you could pass your card around, Eder will eventually get it into my inbox. Thank you. Yeah, so we're solving for missing side lengths. You can even do a preview down here. In example 1, we have 6, 8, 10, 9, 12, x. How do we find x? That's the whole point of today. If you can do that really easily, you're going to say, okay, if it's a 5, or if at least you're confident, and it might not be easy, you're going to give me that 5. So from yesterday, we had the side similarity theorem. I'm doing the same thing right now, so you can pull back from your notes 4-1 and look back and say, oh yeah, I know how to do that. So if I have these two triangles, if I have DE, the bottom of the triangle, that should be proportional to AB. I need two other fractions. A fraction here is equal to a fraction here. What goes here, what goes here, what goes here, what goes here? I need one volunteer for each of these fractions. Help me out. Who's got this? Notice that DE was the big, so I'm really saying the big divided by small in this case. So make sure you're doing big divided by small. Yeah, Andres.
FE divided by CB.
FE over which one?
Over line of, yeah, line CB.
Line segment CB, yeah.
Yeah, line segment CB.
Yeah, perfect. Thank you. I'll take your card. And someone else do another one.
Thank you.
Sergio.
EF.
Oh, we just did EF or FE. So we have the
okay.
bottom and we have the hypotenuse.
Is it ED? No, never mind.
This left one. Go do this left one, Sergio. You got this, Sergio.
No, it's just like a confused one. Because I did it on my own.
Okay. Go ahead and just do this now. So left side,
EF,
DF,
AC.
and AC. There it is. Everyone has it written down. Just know that you kind of just set up the sides. You have to do corresponding sides. That's what's the technical definition of it. Corresponding sides just means, hey, if you're doing the hypotenuse, make sure you're comparing it with the hypotenuse. Compare the similar things. Okay. We had a word for that, starting with a C and then an R. Does anyone remember what that word was for whatever these numbers are equal to? This number has a name. Maybe it's like 3/2, it's a fraction. But what is the name of that fraction? Look back at your notes if you don't know. Everyone should be raising their hands after looking back at their notes. I have a lot of good model students that are looking back at their notes. This ratio is known as the what? Do you have your card, Andres?
Yeah, no, maybe. No, I don't.
All right. I'm going to give it to someone that has their card. Gunnar, did you want to participate? You don't have your card. Sergio, you need to pass that in. All right, Andres.
Are you sure it's not the skill factor? It's not skill factor.
Oh, I was thinking of something else. It is the skill
That's
factor.
a teacher,
It is, yeah.
Yeah, I was going to say that.
I was thinking of common ratio, which is another word that I guess I could use to explain it. Yeah, sorry about that. It is totally the scale factor.
Were you ever going to do ratios this year?
We just did the ratio. Look, those are ratios.
Like
actual-
point. You know.
You're talking about like sports ratios?
Something to something.
I don't remember ratios. Like, oh, it's something to something. I don't remember ratios, so it's been a while.
Okay.
Just go over them.
Here, let's do a ratio right here.
No, I'm just kidding.
So, I need to have some sort of equation with ratios. Whenever you're doing a similarity problem, you're going to have some ratio on the left-hand side is equal to, maybe I should do this in black so we can have this color-coded. Some ratio on the left-hand side is equal to some ratio on the right-hand side. So I just have to figure out a number here, a number here, a number here, and a number here. One of those numbers should be x, because that's what you want to solve for. So, someone set up a similarity statement between a small and a big triangle. I don't care if you do big over small or small over big. to help us solve. And I can't choose Sergio or Andres. Sorry, you guys have your card in. If it's a question, though, I can definitely answer the question. Gunnar, yes.
9/6.
9/6. Let's do it. Someone else can do the next half. We're doing the big red big red side of the triangle over the small blue side of the triangle. 9/6. So the red I'm going to consider to be big. And then the blue I'm going to consider to be small. All right. So somehow I need to have an x. Where do I put the x? Yeah, Fernando.
X over 10.
X over 10 is indeed correct. X over 10.
You do 10 over x.
You cannot do 10 over x because it's always going to be the big divided by small or the red divided by the blue. If you flip that, then it's not going to be a true equation. So this is what I consider to be at least the hardest part. This is the new knowledge that you're learning. And then from here is kind of review. If I have a fraction equal to another fraction I'm trying to solve, what do I do? Quiet raise hand. Who's got this?
Can I ask an on-task question?
Off-task question is going to have to wait until after.
On-task question.
Oh, on-task question, yeah.
If it's x, how can you be so sure that it's bigger than 10? It could look bigger, but...
I'm going to assume that this is drawn to scale. This looks...
If it is the same time scale, you don't know.
That is a good...
Yesterday you did say do not assume.
Because, so we can't assume, you're right in mathematics, but because this says, hey, triangle ABC is indeed, it is telling us the given information, so we don't have to assume that these are similar triangles, which means we can set this up. We know that x is bigger than 10 because these are corresponding sides, and we already know that the red triangle is bigger than the the blue triangle because 9 is indeed bigger than 6. All right, so quiet raised hand. What do I do? Here's your hint. You do this to the fraction. What is that called? Quiet raised hand. Who's got this? I see 3 hands, but none of them have cards. I'm going to start cold calling on people. Oh, yeah, Jenny. Indeed, you cross multiply. So let's do that. Another quiet raised hand. Who can do that for us? Let's do that one first. Who has their card? Jose, you have a card? Yeah, go for it.
So 6x?
6x. And then cross multiply the other direction for us as well, Jose. Let's cross.
90?
Is equal to 90. There it is. 6x is equal to 90. That's what happens when we cross multiply. Another quiet raised hand. What do I do from here? Come on, you guys got this. Algebra 1. Do you have your card still, Fernando? No, you don't.
Yeah, I haven't answered it.
You haven't answered? Okay, go for it. Turn it in as you're doing it, though. Pass it around. Yes.
You divide both sides by 6.
Divide both sides by 6. There it is. The 6 cancels out. I have x is equal to, and then I can reduce this side. Fernando, it's still you. What could I divide the top and bottom by? You can start small.
3.
3, okay. Divide by 3, divide by 3. 90 divided by 3, Fernando is?
30.
30. 6 divided by 3?
2.
Okay, keep dividing.
Divide both sides by
2, and I get?
15. Which is just 15?
Just 15, yeah. 15 over 1 or just 15. And there's our answer. X is 15. Done. Final answer. Box it. Question, I'm guessing, Sergio? Yes.
How can you like prove it? Like,
Yes, no.
no, it's like go like backwards and I don't know. Like how can you?
Oh, yeah. Okay, let's try it, right? So if I prove this, theoretically what should happen is I should have 6 over 9 should be equal to 8 over 12 should be equal to, now this is 15, so I can come down here and say, yes, this x is 15, so it should be equal to 10 over 15. All 3 of these should be the same proportion, to be similar. This is coming from yesterday. We're trying to prove this. Well, if I reduce each of these ratios, if they're the same number, then we have proved it, right? So, and this is kind of how you check your work as well. I'm going to divide the top and bottom here by 3, and I'm going to get 2/3. 2 over 3. Nod your heads if you agree. Okay, let's divide 8 over 12 by 4 and 4. 8 divided by 4, 2. 12 divided by 4, 3. 2/3 and 2/3. So far, so good. And to finally complete the proof, we need to make sure that this is also 2/3. Let's divide the top and bottom by 5. 10 divided by 5, 2. 15 divided by 5, 3. Woo, there they are. 2/3, 2/3, 2/3. We have now proved it. Thank you. Good question. Gunnar.
Will there ever be a case where you cannot solve the triangle?
Yes.
How?
If I give you no information. If I said, you don't know those two lengths now it's impossible to solve.
No, not really. If those are both X, you just do that.
Well, then I'm giving you information. If they're X, then you could solve. If I didn't even have that information, though, you couldn't solve. So it's possible that I didn't give you enough information. Let's move on to example number 2, and then we're done because there's no backside. I want you guys, there's decimals, so be careful. Remember, to get rid of decimals, if I have something like 1.5 over 2, in order to reduce that fraction, first multiply to get rid of the decimal, so times 2 times 2, and then I'll get 3 over 4 and then be done. So to get rid of decimals, go backwards, multiply instead of divide, and then you can reduce if you need to. So you guys are all going to be doing this by yourselves or in small groups of 2 and solve for n. Good luck. All right, so who can help me set up a proportion? I will only give this to someone that has a card, which means I might have to cold call on someone. Sorry, Jenny. All right, if there's no one that I can cold call, or if there's no one that's going to raise their hand. All right, Cohen, go for it.
Alright. 14 over 10.5. 6 over n.
And 6 over n, perfect. Thank you. And then there were 2 different ways of starting this problem. This is the first way of starting the problem. Can anyone give me another way of solving the problem? We're going to go through Cohen's, and then we're going to go through someone else's. Again, it's someone that has to have a card still. So it kind of limits it to 4 people.
How can you be so sure that they have that other answer?
Because I saw them.
Sure.
Well, those 4 people I actually did not check. All right, yeah, Jessica.
What am I supposed to do?
Give me another. So 6 over n could be equal to something else too. I could have had 6 over n is equal to something, but that's not 14 over 10.5. So 6 over n is equal to not the 14, not the 10.5, but what over what?
12 over 9.
Exactly, 12 over 9. Thank you. So it's going to be blue 12 over the red 9. So either one of these will start you off on the problem. You might think, okay, well, that one's a little bit easier because it doesn't have a decimal, but this one will come out to the same answer. You'll get the same answer no matter what. So let me go through Cohen's answer, and then we can go through this through Jessica's answer. So cross multiplying, 14 times n is 14n. Cross multiplying the other direction, 6 times 10.5. Well, I know, is it 30? So it's 60, and then I have to do 0.5 of 6, which is 3, so 63. And then I would divide both sides by 14 to isolate for n. So divide by 14, divide by 14, and I get n is equal to 63 over 14. Notice that the top and bottom are both divisible by 7. Divide by 7. Divide by 7. 63 divided by 7 is 9. 14 divided by 7 is 2. Oh, that is 4.5, Andres.
I told you.
You did tell me.
So that's teaching.
It is indeed. Let's cross multiply the other direction. We should still get the same answer. Let's see here. If I cross multiply this direction, 6 times 9 is 54. If I cross multiply the other direction, n times 12 is 12n. Now I just need to divide both sides by 12. So divide by 12. Let's do this in red. Divide by 12. Divide by 12. And n is now isolated, but I don't know what 54 divided by 12 is in my head. So I am going to rewrite this. I'm going to say n is equal to 54 divided by 12. And let's kind of zoom in here so we can reduce our fraction. 54 divided by 12, I can divide the top and bottom by 2. Divide by 2. 54 divided by 2, that's 27. And then 12 divided by 2 is 6. Oh, they're both divisible by 3. How do I know that? Well, add them. 2 plus 7 is 9. 9 is divisible by 3. So they're both divisible by 3. Divide by 3. Divide by 3. And my new fraction, my final answer, well, not final answer, I don't think. Or is it? So 27 divided by 3 is 9. And then 6 divided by 3 is 2. And then look, 9 halves, 9 halves. We get the same answer. The full answer here is 4.5. So 4.5 is the answer. We got it 2 different ways. Zoom back out here. So that means n is 4.5. Now is a perfect time to ask me on-task questions. On-task questions. Do you have any questions about example 1 or example 2? Gunnar?
No, I don't. I was going to ask an on-task question about off-task question.
That would be an off-task question. All right, so give me a fist of 5 for the objective. How well can you solve or use properties of similar triangles to solve for missing side lengths? Everyone give me a fist of 5. I see a 3, a 4, a 5, a 3.5, a 4, a 4. Cohen, you're at a 4, a 4, a 3. What is this? 2.5, a 4.
I can't move this one though. 0. It's 0.
3.5? Okay. All right. So that concludes this lesson. You guys now have a minute break while we get ready to do some homework on Khan Academy.